Students, this is a continuation of our previous video where we have in our previous video already we have proved property 8. Now in this lecture we shall prove these two, that is property 9. So first we shall prove that if A is equal to B, A is equal to B if and only if alpha cut of A is equal to alpha cut of B. So let us see the proof of this statement. So students, first let us assume that A is equal to B and we shall prove that alpha cut of A is equal to alpha cut of B. So let us first assume that the fuzzy set A is equal to the fuzzy set B. Now by the definition of equal fuzzy sets, we know that two fuzzy sets are equal if their membership grades are equal. That is, this can happen only if the membership grade of the element X with respect to the fuzzy set A is equal to the membership grade of the element X with respect to the fuzzy set B, and this should exist for all X or an element of capital X. So first we shall assume that A is equal to B, and because A we have assumed this, the membership grade of X with respect to A, that is A of X, will be equal to B of X for all X an element of capital X. Now we have to prove this, that is to prove alpha cut of A is equal to alpha cut of B. Now these two are crisp sets. So if we want to prove that these two sets are equal, in crisp set, by the concept of crisp sets, if we want to prove that two sets are equal, we have to prove that they are subsets of one another. That is, first we have to prove that alpha cut of A is a subset of alpha cut of B, and second we have to prove that alpha cut of B is a subset of alpha cut of A. So by these two we can prove that the alpha cut of A is equal to alpha cut of B. So first let us prove this. So to prove this, we shall assume one element from alpha cut of A. So let X be an element of the alpha cut set of A. So if X is an element of the alpha cut set of A, it implies that A of X is greater than or equal to alpha. Now if because A of X is greater than or equal to alpha, we have A of X to be equal to B of X. So this can be because it is equal to B of X, we can write this as B of X. Instead of A of X, we can replace it by B of X. So B of X will also be greater than or equal to alpha. But we know that if B of X is greater than or equal to alpha, it implies that X is an element of alpha cut of the set B. So we started with an element to be an element of alpha cut of A, and we have proved that X also belongs to alpha cut of B. So this proves that alpha cut of A is a subset of alpha cut of B. So we have proved this first one. So now let us prove the second one. So to prove the second one, first let us assume X to be an element of alpha cut of B. Now because X is an element of alpha cut of B, by the definition of alpha cut, we know that B of X is greater than or equal to alpha. Now because B of X is greater than or equal to alpha, here because B of X is equal to A of X, we can just replace it by A of X. So it is greater than or equal to alpha, and this implies X is an element of alpha cut of the set A. So now we started with an element from the alpha cut of B, and we have proved that X also belongs to alpha cut of A. So this proves that alpha cut of B is a subset of alpha cut of A. So we have proved 1 and 2, and by this we have proved that alpha cut of A is equal to alpha cut of B. So we are done with the proof of this part. That is the first part of the ninth property. Now what is the second part? That is the converse part. Actually we assumed this and we have proved this. Now the second part will be the converse part, that is we have to assume this and we have to prove that the set A is equal to the set B. So let us see the proof. First we shall assume that the alpha cut of A is equal to alpha cut of B. So in the converse part, let us assume that alpha cut of A is equal to alpha cut of B. Now alpha cut of A is a crisp set. Alpha cut of B is also a crisp set. Now in set theory, two sets are equal if one is a subset of the other. That is, alpha cut of A will be a subset of alpha cut of B, and alpha cut of B will also be a subset of alpha cut of A. This is by set theory. So because of this assumption, we get, that is, it implies that alpha cut of A is a subset of alpha cut of B, and also alpha cut of B is a subset of alpha cut of A, because they are equal to one another by set theory. For crisp sets, we can write like this. So now what does this imply actually? That is, this alpha cut of A is a subset of alpha cut of B means that if we take an element from alpha cut of A, it will also be an element of this, that is alpha cut of B. So from this we obtain that if we consider x to be an element of alpha cut of A, it will imply that x is an element of alpha cut of B. And also, what does this imply? If we consider an element from alpha cut of B, it will be an element of alpha cut of A. So this implies that because this is a subset of this, if we take an element of alpha cut of B, then it will imply that x also belongs to alpha cut of A. Now what do we mean by x an element of alpha cut of A? We mean that the membership grade of x with respect to the fuzzy set A is greater than or equal to alpha. Now this will imply that the membership grade of the element x with respect to the fuzzy set B will also be greater than or equal to alpha, because this implies this. We can say that this implies this. And also, now x is an element of alpha cut of B implies that the membership grade of x with respect to the fuzzy set B is greater than or equal to alpha. And this implies that x is an element of alpha cut of A, that is, the membership grade of A with respect to the x with respect to the fuzzy set A is greater than or equal to alpha. Now from this, what do we get? A of x greater than or equal to alpha implies that B of x is greater than or equal to alpha. By this we can say that B of x is greater than or equal to A of x, because this implies this. Therefore, B of x will be greater than or equal to A of x. Because A of x greater than or equal to alpha implies that B of x is also greater than or equal to alpha, and this can happen only if B of x is greater than A of x. So we get this. And what about this here? B of x greater than or equal to alpha implies that A of x is greater than or equal to alpha. What does this mean? What do we understand by this? A of x is greater than or equal to B of x. So A of x is greater than or equal to B of x, because this can imply this only if A of x is greater than or equal to B of x, using the same concept that we used here. And now B of x is greater than or equal to A of x, and also A of x is greater than or equal to B of x. And when can this happen? Only if A of x is equal to B of x. That is, the membership grade of x with respect to the fuzzy set A is equal to the membership grade of x with respect to the fuzzy set B for all x to be an element of capital X. And when two membership grades will be equal, they will be equal only if the fuzzy sets are equal fuzzy sets. That is, the fuzzy set A is equal to the fuzzy set B. And so we have proved. So by assuming that alpha cut of A is equal to alpha cut of B, we have proved that the fuzzy set A is equal to the fuzzy set B. So that is what the converse part says. So carefully you have to understand these two steps, okay, because it is happening simultaneously. The reason is because they are two equal crisp sets. One will be the subset of another. So when this is a subset of this concepts hold, and when the other set is a subset of the other, that is alpha cut of B is a subset of alpha cut of A, these concepts hold. So when we have both the concepts together, then the membership grades become equal, and the membership grades can be equal only if the fuzzy sets are equal. So by assuming this, we have proved this. Hope you have understood the proof of this part also. Now the same concept has to be proved for strong fuzzy sets, because we have in the theorem, strong alpha cut sets of a fuzzy set. So in this theorem, just now we have proved that if A is equal to B, if and only if, A is equal to B if and only if alpha cut of A is equal to alpha cut of B. So this we have proved. In a similar way, we have to prove that A equal to B if and only if strong alpha cut of A will be equal to strong alpha cut of B. And the proof is absolutely the similar, the only difference being, now here you will be having strong alpha cut wherever you have alpha cut, and alpha cut of A or alpha cut of B, it will be strong alpha cut of A and strong alpha cut of B, and because of that this inequality will be strictly greater than, so A of x will be strictly greater than alpha, B of x will be strictly greater than alpha. So wherever you have greater than or equal to, you have to just replace it by only greater than, because we are dealing with strong alpha cut in that property. So we will be hence we will be proving both the this part and the converse part also with the same method. Now instead of greater than or equal to symbol here, we will be having only greater than symbol when we prove this, that is this property. So the proof of this is absolutely similar to this, the only difference being greater than or equal to, wherever you have greater than or equal to, you have to replace it by only greater than sign. So what you can do is you can take it as an assignment and you can finish it. Okay, hope you have understood these concepts, the proof of all these 4 properties. Thank you.